In the previous part, we saw how to install Python, how to create a basic hello world program, how are variables used, how can strings be used, and how collections or lists can be used, and how if-else statements can be created in Python, while and for loops, dictionaries and tuples. In this video, we are going to see time calendar modules, how to create functions, how to create classes, how to overload methods and private variables inside Python.
Press the bell icon on the YouTube app and never miss any update from Tech Primers.
Let's start off with using the time and the calendar modules. I'll create a new class called example3. In order to import the time module into this particular class, we need to use the import command. Like any other language, this import is going to bring in the time functions into this particular file. So we can access the time specific modules using the time variable, like how we imported. We can do a time dot and then do some stuff. So there are lots of suggestions provided by IntelliJ by default. If you are using IntelliJ, IntelliJ has very good support for Python. So you can notice it by default shows up what are the different functions which are available in the time module. I'm going to use the time.time and let's do a print, and let me run this program. So time.time will print the current time in float. So this is nothing but the time calculated from the epoch time in terms of ticks. So the number of seconds which have occurred after the 1970 time. January 1st, 1970, that is the basis for the epoch time calendar. From that time, how many seconds have got passed until this moment? So that is the number of count here. So in order to make it in a more readable format, we can use the time dot local time, and we need to pass the seconds here. So in order to get the seconds, we need to do the same time dot time, and let's run this. So we got the seconds using the time dot time, and we are passing those seconds to the local time. If you notice, we are getting a structured time which has different variables, and we need to extract the variables out of it. However, if we want a much simpler version, we can do time.ase time, which needs another tuple, which will be time.local time, again time.time. So this will print us the time in a much readable format, like how we used to see in Java or C or C++ or even JavaScript. So it shows Saturday, February 3rd, 11:40 a.m. and 2018. So these are the different functions which are available inside time. The next one is the calendar. In order to use calendar, we can use the same import statement to include the calendar library. IntelliJ has the intelligence to show us what are all the different libraries which are there, which are starting with CAL, right? So you can notice the calendar library is present in my Python installation folder. So what does calendar provide? So calendar provide different methods like sleep. If you want to identify whether a year is a leap year or not, let's check if 2018 is a leap year. It is not, right? And if you put 2016, it should return true. So these are some methods which are available out of the box for us, so that we can directly use it from the calendar module. So some more functions inside calendar could be leap days. So it shows how many leap years were within a year range. Let's say from 2000 to 2016, how many leap years were there? So this leap days will calculate how many leap years were present between these 2 years. Similar to that, we have calendar dot month. which can give you the current month's calendar. So let's say 2018 and the month is 2, it's February, right? And let's do a print. Okay, IntelliJ shortcut did not work. Print, I think calendar.month by default had a printable method, that's why print did not work. Okay, so you can see the calendar of February 2018, that's what we have mentioned here. So those can be used whenever you want to use the date and time functions. You can use lots of methods inside calendar. Calendar also even has the day, year, and lots of other methods are available. You can just check that in IntelliJ or even check the Python documentation. The next one is functions. How do we create functions? So in order to mention a function, we need to define the keyword def. This will tell the Python interpreter that my data type can be anything. So def generally denotes anything. Let's try creating a function called function, and there is no curly braces as such in Python. It all works on the colon. So if I define a function like this, I haven't mentioned any argument. Let me define an argument, let's say arg, and I need to use the tab space so to define that the function scope is started. I'm just going to do a print of arg, or let's say inside function. I'll just say arg. And how do we call these functions? The functions can be directly called as this. Let's say I pass this. I'll just pass hello YouTube. Let me run it. You can see the function has been called with integer and even with string. So that is the advantage of the data types in Python. You don't have to define a data type, and you can have different return types as well. If let's say I want to return value, let's say I want to return success message, I can do that. And how will I get it printed? I need to do a print. If I do a print, this is going to return me success. See that the return type has come here and we are able to print it. There is one more way of calling functions. We can have multiple arguments. Let's create one more function. I'll create it as 2, and I'll just say argument 1 and argument 2. I'll even rename this argument 1 comma argument 2. We can do argument 2 we can do argument 2 equals hey, and argument 1 equals, let's say, howdy. See that argument 1 and argument 2 were currently correctly printed even though we had passed it in a different sequence. The only thing is we are using the key to denote that this is the value for this particular key. Python has this new functionality where you can interchange the arguments. However, if you have the key mentioned, the interpreter will identify and map the values to the corresponding keys. So this is how you can use functions in Python. So there are lambda functions as well. You can use lambdas in Python as well. So let's see how to create that. In order to use the lambda functions, we have to define the function with the keyword lambda. Let's create the third function. We need to assign these lambda functions to a function variable. So I'll create a lambda. I just say lambda, and we need to pass two arguments. I'm just passing argument 1 and argument 2, and similar to how we open the curly brace or how we open the scope for a function, we can use colon to open the scope for the lambda function, and we can just say print inside lambda function, and I'll just print argument 1 and argument 2. That's it. So this is how you can define a lambda function. The lambda functions will be useful when you have function within a function and you want to do complex operations and you want to change the functionality based on some implementation. That's when it is very useful. But in our case, I don't think I will be able to show you the exact usage, but I'll just show you how you can pass it. So I'll just pass argument one as this, and I'll just say hello YouTube from lambda, and let's run this and see here the lambda function gave hello YouTube from lambda. So this is exactly similar to the function. However, you don't know that it is lambda or not, but when you use a function within a function, that's when you can pass the implementation directly. So you can even pass a lambda here and then you can pass it to another function. So we can see that complex case in the coming videos, but for now just know that lambdas can be used inside functions in Python. The next up is classes. How do we create classes in Python? Like how we created the lambdas, classes also have a keyword. It's called class, and we need to define a name to a class. Let's take our usual example, the user. Similar to how we open the curly brace in any other language, we need to use the colon for opening the scope for this particular class, and we can define our variables. So I'll just define the name for that user as Peter by default, and I'll just use the age as 34. How do we define constructors? So we can define constructors by using underscore underscore in a. How do we define constructors in the class in Python? We can use the underscore underscore init. This is the constructor definition in Python. So any class, if we create a class, the constructors can be created using the underscore underscore init, underscore underscore, and self. So self is nothing but the object. The current object is given to the constructor as well. And we can do, let's say, self dot creation of assignment of name. We can do here as well. Let's say I want to override those names. Let me try overriding them, right? I can do this. And I'll create one more function. So we saw how to create functions, right? We need to do a def and then we can write a function. I'll just create a print function. So whenever you create a function inside a class, we need to have the first variable as the self, which will be the instance or the access to the current object. So this is similar to the this operator in Java. You can think of self as a this operator in Java. I'm just going to do a print, the basic print, saying printing values or printing user. I'll just print the self dot name and self dot age. So we have created a class, we have created a constructor, we have created a print method, which will just print these values which we have created as a part of the object creation. I'm now going to use this class. I'm going to create a new object of that class. Let's say user equal to. There is no new keyword which we can use. We can directly do a user of, and we didn't pass any argument, so we don't have to pass anything. By default, self is injected by the interpreter, so we don't have to pass that. So the current instance is provided to the constructor. For identifying whether the constructor has loaded or not, let's add a log here and let's print this user, and I'll just add a print statement. The constructor got loaded before the Sam and the age 35 got printed. Notice here we have overridden Peter and Peter's value. If I remove this particular piece of code, or if let's say I comment it out, see the Peter's name is still retained. You can override stuff in the constructor. If you want to provide a argument constructor, we can provide a argument constructor, name, age, and let's assign the name here, and we can assign the age here. So when we create a user, we can provide the name and age. I'm going to provide Ryan with age 45. Now we should be able to print Ryan's age because we have overridden the Peter's age using the constructor. So this is how we can create a constructor. So there should be a destructor as well, right, which needs to clean up this data. There is a destructor and we can even override that destructor in Python. So del self, this is going to be a destructor, so we can define underscore underscore del underscore underscore. That is going to be the definition for the destructor. We can just do a print and say destroying object. When does this destructor get called? Whenever we do a delete of this particular object in memory, this will be called. I am manually deleting this particular object. If there is a garbage collection which is happening in Python, and if your object is not getting used and Python interpreter identifies that okay, this particular object is not used at all, then the destructor will be called. However, you can manually delete it using the del and the object statement. See that the destroying object has been printed. If I don't call this, if I don't call this, even though I manually didn't call, it is getting called because the object gets garbage collected after its usage. So we saw what are classes. Let's see how to create a parent and child relationship in a class and how do we override methods. We have created a user. I'm going to create a employee. The keyword is class. Employee is the class which we are going to create because employee can be an user. In order to say that this particular class is a child of a particular parent class, we can use the open braces and we can just say I am a child of user class, and we need to start the scope. Here I'm going to have a variable called employee ID and I'll just assign it as 123 as a default value. We can do the same stuff here. We can add a constructor. I'll just add a constructor and I'll also pass the employee number here so that we can override it. I'll just say self.employee ID equal to employee ID. We need also the destructor. I'll just add a destructor so that we can add some print statement, destroying employee object. We need a print statement as well of this particular object, and let's do a print of overridden methods, overridden method, and then let's print the self dot employee ID. See that we have overridden the method called print inside the employee class. So when we create an instance of the employee class, this particular method should be called. And if you see, IntelliJ automatically identified that this particular method is overriding. However, let's see from the Python's interpreter's perspective how we are able to do that. I'll just pass the employee ID as 456 and employee dot print. So the overridden method is 456 and the destroying object has been called as well. So this is how you can override methods in Python. You don't have to define anything. You just directly define the method and just start writing it. Now, how do I define the scope of a particular variable? We have lots of variables which are used here, and if you see, I can directly access the user.name here. I can directly do a print of user.name. Same way with the user.age and with the employee.employee ID. We can directly do this. So how do we control it? I think user has been deleted. Let me remove this. So see that we are able to see Ryan 45 and 456 getting printed as a part of this. After this, the destroying object is getting called. So as I said earlier, I was mentioning that if the object is not used, that's when it will be cleaned up. And though we did not use it immediately, we used it after a while. Python knew that this particular object is getting used later, and then it destroyed only after printing these values here. So how do we control accessing the variables inside a class? We need to mark them as private, isn't it? So how do we mark them as private? We can mark them as private using this underscore underscore option. If we mark a variable as underscore underscore, this particular object turns into a private variable. We need to modify the variable names here as well. Wherever we have the variable name mentioned, we need to modify in every other place. If we are not doing this, this will be treated as a new object. If let's say I did not do this, right? If I assign a new variable called new name, even this will be created. Let's try printing that, right? See that, right? IntelliJ identified that there is a new name variable. So this gets printed. Now the Python interpreter should throw an error because we don't have a access, or we don't have a variable called name because we have renamed it as underscore underscore name, isn't it? Let's try running it and see that there is an error saying user has no attribute name. And let's try accessing underscore underscore name. And if you notice, IntelliJ is not even prompting for it, which basically means there is no access as well. And the same error pops up. Even though we had the variable there, the same error pops up. And let's check that new name, because we created that new name directly from the self and we did not create it initially. Let's see what will be the scope for that. See that there is no error, and you can see the name getting printed, which is the new name. This is the new name here. See, new name got printed without any error. So this is a dangerous thing, because if you name a variable incorrectly, then you are going to face problems in Python, because it will create objects on the fly. It has directly created this new name on the fly without even it being defined in the class. So we should be very careful while creating objects as well. So the naming conventions are very important. If we need to have a private method or a private variable, we need to make it as underscore underscore name. We saw what are the different functions which are available with the time module and the calendar module. We also saw how to create functions, how we can create lambda functions, how are functions used in Python. We also saw how to create classes, how to create variables, how to assign variables, how to create constructors, how to use the destructors. And we also saw how to overload the methods when we have a child class, and how to use the parent class and link it and make it as a overridden method. And also we saw how to create private variables. I hope you guys got something out of this particular video. In the next session, we will just proceed further in using some frameworks, because most of the stuffs are covered here. These are the different basic stuff which we need to know in order to do coding in a particular language. In the next video, let's try and use a latest framework which is there in Python, which is used widely. Until then, meet you again in the next video. Thank you very much.